So this is just a video to help you when you encounter resonance in allylic halogenation reactions. So say I have an asymmetrical system here. So I'm going to start with this guy. I have one allylic position, so that's where my H will get pulled off. But that gives me resonance structures that are not identical to one another. So if I put in here Cl2, I'm going to get two structures. I'm going to get a chlorine right here at that first allylic position, and I'm also going to get this structure as well, where I have chlorine right there. And this is because of the resonance in the intermediate. It gives me two different possible products. Here I have the chlorine on a tertiary carbon, here I have it on a primary carbon, so the tertiary carbon would have the more stable intermediate. So let's take a look at that mechanism. So we'll start out with the initiation step where I homolytically cleave that chlorine bond to get two chlorine radicals. Then that chlorine radical is going to go and react with my H at the allylic position. So again, I'm using single-headed arrows because these are radicals, so only one electron is moving at a time. I'm going to have a meet in the middle, so that spare electron on the chlorine is going to come together with one of the electrons in the CH bond and bring the H with it. The other electron in the CH bond is going to go onto the carbon to leave a radical. So over here, I get a radical intermediate, and I get HCl as a byproduct. Now this radical intermediate is the tertiary radical, and that's where we got that more substituted product from with respect to the chlorine atom. So these two carbons are not going to be equivalent, but I do have resonance between the two. So I've got an electron here that can come into the middle, and then this guy can come into the middle to make a double bond there, and then I have one that goes out onto the end there. So I end up with a new double bond there and a radical at the end. So when my chlorine atom is abstracted and it runs into this intermediate, then I end up getting chlorine substitution at the end. So more than one product is possible, and in many cases more than one product is observed. So when you do the quiz, it's going to ask you for the possible products, and if there is more than one due to a asymmetric resonance stabilized radical intermediate, it's best if you just draw out the mechanism so that you can look and see what do these intermediates look like. Are they the same? And if they're not the same, then you're going to have different products possible.